Good day, everyone, and thank you very much for joining me. My name is Jeff Janukowicz, and I manage IDC's coverage around storage and memory components. I've had the opportunity to be at IDC for the last 13 years, and during my time I've spent looking at solid-state drives, SSDs. I've also had the opportunity to participate in every single flash memory summit since the beginning, many years ago, and this will certainly be one of the most unique, but I'm sure one of the most interesting and exciting for you. Today, I would like to share with you some of our thoughts around solid-state storage, some recent developments, and how we see SSDs continuing to reshape the enterprise landscape. To do that, what I'd like to do is tell you the 5 things that you are going to need to know about enterprise solid-state storage. The first thing you need to know if you are someone evaluating the technology, or if you're just looking to better understand where the technology is going in the future within enterprise storage systems, servers, or within the cloud, is that SSDs are no longer just for niche applications and workloads. Many of you may know Flash from the impact it has had within the consumer and client device markets, ranging from mobile phones, where Flash is found in more than 1 billion mobile phones that ship annually, to PCs, where SSD adoption has grown substantially in recent years, and now is the preferred storage technology. But Flash is revolutionizing the enterprise too. Today, we see broad enterprise SSD adoption across all market segments. And that's because the value proposition of enterprise SSDs remains compelling and aligns with the requirements of many data center and IT managers. What that means is higher performance, the need for faster access to the vast amount of data that is being created, better efficiency, more intelligent use of our assets. For example, tiering, where the most frequently accessed data can be put on Flash, and the use of a lower cost media, like HDDs, can be used to store that cooler data. Cost effectiveness. Flash solutions can provide a lower TCO when factoring in power, cooling, and floor space. And for those performance-oriented applications and workloads, a lower overall dollar per IO. And when taken together, this is translated into broad adoption by server and storage OEMs alike. This includes companies like HP, Dell, NetApp, IBM, Lenovo, Hitachi Vantara, and others, but also with ODMs into cloud service providers like Amazon, Microsoft, and Google. And you can see here in terms of the amount of SSD capacity that shipped last year, it was almost 55 exabytes of capacity. Clearly not a niche. And to reinforce that Flash is no longer for niche applications and workloads and has truly moved into the mainstream. While HDDs have a long, storied history and continue to be an important technology to store the vast amount of data that's being created, the value proposition and advantages of Flash technology has resulted in steadily growing enterprise SSD revenue over the last 10 years. In fact, it has more than doubled in the last 5 years. That's right, more than double. And if you look at 2020, you will notice that spending on enterprise SSDs now outpaces that of enterprise HDDs for the overall enterprise market. So, clearly SSDs are no longer just for niche applications or workloads and have moved into the mainstream for many companies. The second thing you need to know about enterprise solid-state storage is they have become more cost-effective. Many times when I talk to end customers, we hear that SSDs are too expensive for my project or can't fit within my budget. And while they are more expensive than HDDs on a dollar per gigabyte basis, the industry has gone through a period of rapid product advancements. By advancing the technology and moving from SLC, single level cell, to MLC, to TLC, or 3 bits per cell, but also by advancing the scaling and moving from 2D into the 3D era, where the cell structure is now vertical and multiple layers can be added for improvements and better cost. We've also seen continued fab investments by the memory companies to ensure economies of scale are in place to support the overall industry and the expected growth. As a result of these technology advances, it has enabled further cost reductions. In fact, we've seen greater than a 25% compound annual growth rate cost reduction in enterprise SSDs over the last 5 years. And moving forward, we expect enterprise SSD prices will continue to improve relative to HDDs and get more cost-effective in the future. If we compare the price premium of enterprise SSDs, as I'm showing you here, to that of both the performance-optimized HDDs, these are the 10 and 15K hard drives, as well as the capacity-optimized HDDs. Today, SSDs are already cost competitive in performance applications where performance HDDs were used. And you can see that reflected here in the green bars. And you can see that flash continues to narrow the gap over time, even when compared to capacity-optimized hard disk drives, thus helping them become more cost-effective storage technology throughout the enterprise environment. So, SSDs are no longer just for niche applications and workloads and have moved into the mainstream. We just discussed how they have become more cost-effective. With 2 down, the third thing that you're going to need to know about enterprise solid-state storage is optimization helps to unleash the full potential of SSDs. SSDs have some inherent benefits, many of which I already mentioned, but making flash look like an HDD, while initially helped increase adoption by enabling easier integration, it comes with a compromise. Optimizing the ecosystem for solid-state storage unleashes the full potential of the technology. And we see many vendors doing this today. This means adjusting the power and performance levels to suit the overall environment. It means developing different endurance ranges and products to satisfy both read-intensive and write-intensive workloads. It also means moving away from legacy-based interfaces like SATA and SAS that you may be familiar with towards new things like NVMe. It also means of SSD's flexible form factor and optimizing for different architectures, and even adjusting the software and operating system to become more flash aware. We see evidence of this playing out in the industry with the evolution of different SSD form factors. Inherently, SSDs provide the flexibility to provide various options in terms of length, width, height, and can provide a wide array of manageability, serviceability, and thermal considerations built right in. So no longer do systems have to be designed around HDD disk diameters. And today, we are seeing BGA SSDs, M.2 SSDs, add-in cards, and newer form factors like E1 short and long to further this flash optimization. You can see a number of examples here. And there are multiple SSD vendors today providing these solutions, whether it's Intel, Samsung, WD, Kioxia, Hynix, or others. Another area of optimization is in terms of connectivity or interface. And we are seeing interfaces transition away from legacy SATA and SAS to NVMe. NVMe is an open, standardized storage protocol that was designed specifically for non-volatile solid-state media, like NAND flash. It inherently provides faster, quicker access to data, and after many years in development, is now moving into the mainstream. Last year, many cloud service providers began to transition, and that helped NVMe SSDs outship their interface for the first time ever. And moving forward, we continue to see new server designs that leverage NVMe and also the advent of NVMe-based all-flash arrays that will continue to propel NVMe shipments over the next few years, as you can see here. So moving on, I've just discussed how SSDs are no longer just for niche applications and workloads. I've shown you a little bit how we've seen them become more cost optimized. And we just discussed that how optimization will help to continue to unleash the full potential of SSDs. Now to number 4. The industry has seen significant advancements, but the industry is not standing still. And innovation continues to propel SSDs forward. And this will continue to expand SSD adoption in the enterprise market even further. We are seeing innovation in enterprise SSD technology on several fronts. Zone storage, specifically zone namespaces, which will help SSDs and the host to collaborate on data placement such that the data can be aligned to the physical media of the SSD, thus improving the overall performance, cost structure, and increasing the capacity that is exposed to the host. We're also seeing new device categories and architectures, like computational storage and Ethernet SSDs, that both look to overcome bottlenecks within the system. For example, computational storage will offload host processing and reduce data movement to enable improvements in application performance and infrastructure efficiency through the integration of compute resources. The advent of QLC, or 4 bits per cell NAND flash in the enterprise, will look to bring new workloads and price points to flash and to flash solutions. And innovation continues with storage class memory, or SCM technology, that looks to bring a new way to the memory and storage hierarchy. If we look at those last 2 points, QLC is on the horizon for enterprise SSDs. And there are currently several vendors offering solutions. We talked earlier about the move from SLC to MLC and now to TLC, which represents the majority of shipments today. But QLC is a lower cost media than other types of NAND flash, making it more affordable. But inherently, it does deliver lower endurance and performance than TLC. Because of this, QLC-based SSD characteristics lend themselves to read-intense workloads to reduce the overall number of PE cycles. However, we see specific workloads that are use case optimized that are a good fit for QLC technology. These can be things like real-time analytics, artificial intelligence, machine and deep learning, content delivery, media streaming, backup, and other secondary applications. And these will be found in a wide range of applications, ranging from the cloud to CDNs to all-flash arrays and other tiered solutions. And based on our analysis, we expect to see QLC adoption to grow and increase as a percentage of the enterprise SSD mix, as you can see here, over time. And this brings me to the memory and storage hierarchy. For decades, this hierarchy remained relatively stagnant based on existing technologies of the time, primarily hard disk drives and DRAM. But generally, it's been an effective way to balance performance, cost, and capacity requirements. When SSDs were first introduced a number of years ago, they created a new layer within the hierarchy between disk and memory. And now we're on the cusp of adding some new layers. This time between SSDs and DRAM, as new storage class memory and persistent memory solutions look to disrupt the hierarchy once again. Today, we are seeing new media solutions from companies like Intel with its Optane product offering both persistent memory and NVMe solutions, but also new low-latency NAND NVMe solutions from Kioxia and Samsung. And we expect other new solid-state media solutions to emerge over time as the technology continues to advance. And ultimately, the goal of these solutions is to bring the data closer to the compute with a faster media. When we look at this emerging area, we do see significant opportunity for both SEM and persistent memory solutions. As enterprise workloads are becoming more demanding and data intensive, it will lend itself well to these types of solutions. And there are a few key areas where we see this as a good fit. First would be areas where IT managers are looking to accelerate data, such as in-memory databases. The second would be in tiered data storage solutions. For example, using SEM in conjunction with something like QLC SSDs. And finally, in caching applications, where the use of SEM or persistent memory can provide some significant benefits. The good news is hardware architectures are evolving to become SEM and persistent. And we are seeing a number of recent announcements from both large storage OEMs and CSPs about their solution. And as you can see, these solutions are still relatively nascent. However, we do see significant growth over the next few years to further drive this market higher. And today, we do see evidence that many of these proof of concept deployments are starting to move into real sales. So, the 5 things you need to know. SSDs are no longer just for niche applications or workloads and are moving into the mainstream. They have become more cost-effective. Optimization is important to unleash the full potential of SSDs. We just showed how innovation will continue to propel SSDs forward. So the 5th thing that you need to know is that data is the engine of our global economy. And infrastructure needs to continue to evolve to support our digital economy. And with that, we see enterprise SSDs as a critical component of the future of digital infrastructure. And we see this if we look at the worldwide global storage sphere, where we look at the installed base of different storage technologies in the enterprise data center market. If we look at the total amount of new data created each year, it is growing at a compound annual growth rate of around 26%. If data is the engine of our global economy, then we need to find ways to store it and access it in a cost-efficient manner. And flash is a critical part of that. As you can see here, enterprise SSD storage is growing as a percentage of the installed base of the overall enterprise storage capacity, reflecting the growing importance around flash and flash technology. And we are entering a new era within the enterprise market. There are a number of powerful secular trends, including cloud, AI, 5G, and IoT. And this will drive data growth across a broad set of end market applications, ranging from public and private cloud environments to traditional IT, all the way through the edge to endpoints. So if we look at enterprise SSD, we see it growing to support the future of digital infrastructure. In fact, we see it growing at a 24% compound annual growth rate over the next few years. And this makes it one of the hottest technologies today and definitely highlights that SSDs are a critical component within the data center now and in the future. So, in summary, some closing thoughts. As we discussed, SSDs are increasingly important across a diverse set of applications, spanning from the edge to the data center. If you are evaluating the technology, or if you're just looking to help better understand where the technology is going, the 5 things that you should keep in mind are: 1, SSDs are no longer just for niche applications or workloads and are moving into the mainstream. The value proposition is compelling, and we are already seeing spending on enterprise SSDs surpass that of enterprise hard disk drives. The second thing is that SSDs have become more cost-effective. We continue to see flash price erosion, and this will help to continue to expand where SSDs are used in the enterprise. We discussed how optimization is unleashing the full potential of enterprise SSDs. We see new server designs that leverage NVMe and NVMe-based all-flash arrays, and this will continue to propel NVMe shipments into the future. We see that innovation continues to advance enterprise SSD cost and performance metrics. QLC technology is on the horizon, and both SEM and persistent memory solutions present a significant opportunity for companies to differentiate. And finally, SSDs are going to be a critical component for the future of digital infrastructure. Data is the engine of the global economy, and we see enterprise SSD growing at a 24% compound annual growth rate to support all of this growth. And with that, I thank you. And once again, if you would like some more information on NAND flash, SSDs, enterprise SSDs, please feel free to reach out to me or look up some of our research that we've published on IDC.com. There you'll find some perspective on the market, including SSD forecasts, including SEM and persistent memory, as well as data on pricing and other metrics, including additional insights. Thank you once again, and have a good day.